Here we come to A-Level Physics 2000, question 11. We are talking about the experiments for circular motion in this question. So we have a rubber band being pulled by a string connected to a heavy weight. So it is being swung in horizontal circles. So we have already resolved the tension into its vertical, upward component and horizontal component respectively. Upward component is balanced by mg, so t cosine theta equals mg. We can write down this equation. For the horizontal component, t sine theta, it provides the centripetal force, so we can write down t sine theta equals mr omega squared. One more thing is that when we talk about the r, the radius of the circular path, that means this line. This line, the length is actually calculated by L sine theta. So we can write it like this. So let's look at the following statements. The first statement, if L is kept constant, theta will decrease with omega. So we just copy these two equations, but with only one minor change. We substitute the R with the L sine theta. So here, when omega is going to be increased, so when omega increase, L kept constant, we see that sine theta is cancelled out on both sides, so it's independent. So tension will also increase. If tension is to be increased, let's look at the second equation. M and G, of course, it does not change. If tension is to be increased, cosine theta is decreased. Like if cosine theta decreases, the consequence will be theta is increased, because if you have a smaller value of cosine, then the angle should be larger. So if you say theta will decrease with omega, this will be wrong, because when omega increase, theta should increase as well. So this is incorrect. Now for the second statement, let me copy the equations governing the motion. Same set of equation. So here it says, if theta kept constant, L will increase with omega. So we are talking about, of course, the sine theta is cancelled out. Now when theta kept constant, cosine theta is also kept constant. If we have mg being constant, the consequence is t would also be a constant. Now I repeat, now theta kept constant. On the right hand side, mg is also constant. So everything constant, that means t is also constant from the second equation. T is constant. So if omega is to be increased, then L has to be smaller, because other things are constant. One thing bigger, the other thing on the same side is smaller. So when you say when you say L will increase with omega, this is wrong, because when omega increase, L should decrease. So statement 2 is also wrong. Of course, if you can decide 1 and 2 is wrong, then the answer should be 3 only. However, let's take a look on it. It said that when W increase, W is the weight of the standard mass. So when W increase, theta will increase. What would happen when W increase? We know that the tension in the string is equals to W, because they have to be balanced. So if W increase, tension will also increase. So when tension increase, what happens? We can look at the equation. T cosine theta equals mg. When tension increase while keeping m and g the same, cosine theta will decrease. We have said before, when cosine theta, the whole thing decreases, theta will increase. So as a direct consequence, theta will increase. So if you say when W increase, theta will increase, this is correct. So the first statement